Hi, my name is Madhav Sathe. In this short video, we are going to establish that the mTLS between GoRouter and application instance works and how does it work. This is a very short video. It doesn't go into details of the mechanics of how the mTLS actually works, but it's more of a proof that the mTLS actually works. So let's take a look at this application that we have here. I have a very simple application that prints that just gives a simple string in response to a request. And this application currently is running on the PaaS environment that we have here. To ensure that the application instance actually uses mTLS, you have to go ahead and verify in the PaaS tab, go to the application containers tab, and verify that the router application identity verification is set to mTLS. Without this, there will only be TLS, but not the mTLS. So we have to make sure that this configuration is correctly set. Once this is done, you have to go ahead and get the IP address of the compute node, and also the TLS proxy port number on the Diego cell. For that purpose, we will log into the SSH login to the application and grab some of the environment variables. So here we are interested in the IP address of the container of the Diego cell, not the container. This is the container IP address. This is of no use to us. We are interested in the Diego cell IP address where the application is running, and also the external TLS proxy. If you notice here, the external TLS proxy is mapped with the internal TLS proxy. This is the port that is managed by Envoy, and that is mapped to a port number 61006 on Diego cell, that is this particular VM. So we have to make an attempt to create a connection on this secured connection on this IP address and this port, and make sure that it fails without the client certificate, that is the certificate of the GoRouter. So let's go ahead and do that. We have here a GoRouter. We have logged into the GoRouter machine, and if you look at the current directory, it is where we kept jobs GoRouter config. If you go to this folder, there will be a file here called GoRouter.yaml. So go to the GoRouter.yaml file, search for backends. In the backends, there will be a certificate as well as a private key. This is the private key and the certificate that will form the key pair that will be necessary for the mTLS handshake. So you take this, like the RSC private key value and the certificate value, and copy it somewhere. In this particular case, for demo purpose, I have copied it onto the Opsman machine, and I have it here. I have the file here called GoRouter client key pair. So if I just VI to the file, VI GoRouter client key pair. And the syntax of this file is that the first, it has to be the RSA private key, followed by the actual certificate. So make sure that there are no spaces, there is no indentation issues, all the strings removed. The only thing that this should contain is the RSA private key followed by the actual certificate. So once we have this file taken from the GoRouter.yaml on the router VM, we can actually go ahead and make the connection here. So as we discussed earlier, we want to make the HTTPS connection on the compute node that we have here. And on the TLS proxy port of the Diego cell. So if you see here that the handshake actually failed. This means that the client is unable to verify itself and the handshake has failed. Now we will try the same command passing on the client key pair of the GoRouter. Go. And key pair. Now if you see, as soon as we passed on the key pair of the GoRouter, pretending to be GoRouter, the application request, application request was successful. Now on the same port, same VM, if we try to again without the key pair, the application request fails. With the key pair, the application request succeeds. This actually proves that the mTLS between the GoRouter and the application instance actually works. This is a good quick demo. This doesn't go into the mechanics of how it works. I will record a separate session for this. Thank you.